Hi, welcome back to a new video. I have a new REPL here, and in this directory I have two images. This giraffe with a green screen as a background, you see, and we have the safari. And in this video what we will do is we will remove the background, the green background from this picture, and we will overlay this giraffe on top of this safari image. So the output will be this image with a giraffe here on top. So what we are doing is we are applying the typical green screen removal technique, which is typical in TV or other media. And basically it works like this. So in studio they have a green screen on the back, and then in post-processing what they do is they replace those green pixels, which are very unique compared to the other pixels of the scene, and so they replace them with another image. So the output is something like this here below. The rule here is that there shouldn't be any other green pixels except those of the green screen. So the person here shouldn't be dressed in green, because the software has to distinguish, has to remove all the green pixels. So if it removed the pixels of this dress, then this background would also be somewhere in here and not where it was supposed to be. So I hope you get the idea. That's what we're doing here. We're removing these green pixels, and then this is a background where the giraffe will be placed. So let's do that. So I imported OpenCV and I created two image objects. The foreground image, which is a giraffe. So with imread, I loaded the giraffe.jpg image. And then I have another image, the background, which corresponds to the safari.jpg image. Now I told you that the software, which is Python in this case, has to remove those green pixels. So therefore the software has to know what is the value of those pixels. So let's find it out by printing out perhaps, so we have the giraffe, right? Let's try to print out a pixel from somewhere in here. So let's try foreground. Let's print the pixel 40. So it should be somewhere near the corner, somewhere here, I suppose. And so this is the value of that pixel. So the green pixels have this value: 28 for red, 255 for green, and 76 for blue. So which makes sense. So I think this kind of color has this combination of colors. So it's not 100% green. It's not only 255 for green and 0 for red and 0 for blue. It's somehow bluish. Anyway, that's not our job. Our job is that we know now what pixels we should remove, and we are ready to go further and iterate through foreground. So for I in, what do we iterate through here? Well, I think we should iterate through range width. What is width? Well, width could be a variable we create here, equals to foreground shape 1. So which is, so let me print it out, foreground.shape gives us this here. So 480 is the height of the image, 852 is the width. Let's check that. Yeah, so this is the height, 480, and this is the width. Therefore, if we apply the index 1, we get that value. So that's the width. Right. Let's uncomment that. What I am doing now here is that I am iterating over all the columns of the image. So range width, I can print out I just to see what we get. So we are iterating 851 times. So 851 times. Actually, 852, but this starts from 0, so this range is an object that starts from 0 and goes up to 851. So it has 852 elements. That means we will iterate 852 times over the width, right? Now, what do we do in each iteration? For each iteration then, so let's say this is the first iteration somewhere in here, and in that iteration we iterate again for j in range height. So height is foreground dot shape 0. So we have a nested loop here. Now we can extract each pixel in this iteration foreground ji. So that gives us the current pixel of the image. So ji, not ij. Now let's see what this pixel prints out. So print pixel, and you'll see that we get a long list of pixels. So it's still being printed out. Every single pixel of the image, which is basically, it's around, I think it was 439, the width, times 851. So that's a lot of pixels if you multiply these two. So that's the total amount of pixels. And now that we have access to this pixel, to the current pixel, we can write a loop such as if pixel is equal to the list 28, 250, 76. So that was the green pixel, right? So the loop ended here. So if the current pixel is that pixel, is a green pixel, let's say if the current loop is at this iteration and that is equal to that, in that case, what we do is we access the foreground image, so the giraffe, we access the cell, the pixel with these coordinates, so ji, the current pixel, and we change that pixel to something else. So this will modify the current pixel. We change that to background ji. So for example, if the current pixel is this one in here, somewhere here, then we assign that pixel the new value. The new value is background ji, which is something like this sky here, right? And that replacement happens only when we're iterating over a green pixel. Right, I hope that is clear. And then all it's left to do is go outside of the loop and say cv2.imWrite, assign a new name for the output image, output.jpg, and we want to write, so guess what we want to write here, the foreground or the background image object. I think it's a foreground, because it's the foreground that we are changing, we are replacing the green pixels with those pixels. So the foreground is written in that file. Let's run and fix a few errors that we'll get, because this is still not ideal. So I have to go down on my terminal. Yeah, so this is the first error in this line 15 here. So the truth value of an array with more than one element is ambiguous. What's happening here is that pixel is actually a numpy array. So if you print out here, print type of pixel, we're going to see that this is a numpy array. But then we are comparing that numpy array with a Python list. This is a plain Python list, and you cannot do that. So one workaround is to convert this pixel into a list. So this numpy array, we convert it into a list. Therefore, these things here now, this is numpy array, that will be converted into something like this, a list with these commas, and that means this is comparable now. So we can run the script. We get this printed out, so let me remove that print function, comment it out because it takes a lot of resources and we don't want that. So run again. You see it's running now. It should take a few seconds. Yeah, it's finished. And let's check the output. Okay, so something is working, but it's not ideal, but we can fix that. So we have two problems here. The first problem is obvious. We still have these green areas around the giraffe. Why is that? Well, that is because not all the green here has a pixel value of 28 to 55 and 76. Some of the pixels, such as those who are very close to the giraffe, so near its boundaries, they will have a slightly different green, which is a bit interpolated with the giraffe brownish colors here. So this, in other words, these pixels here are not the same as these ones in here. And our script here is very strict. So the conditional is only comparing that particular pixel color. So that is one problem. The other problem then is, if you see the original image, we have more zebras here, but the output looks a bit zoomed in. So what OpenCV did is that it tried to fit the original image, which has a small size, into this bigger size image. So basically it zoomed out in the center and then placed this image. So we can fix that too. Let's fix these issues. First, the pixel issue, the green pixel issue. What you could do is you could say np for numpy, which needs to be imported here. So import numpy as np. So np.all, and then you say pixel is equal to that, and close the parentheses. Actually, any is better. I'll explain you why. So I ran the script, and let's check the output. So now it's slightly better. We still have lost some pixels from the giraffe ears here, but I think it's still better than it was before. We can also improve this by saying, instead of that, I would just say 1 to 55, 0. For example, you can play around with different pixel values and see what works best. So what I just did here is that I put a more typical green, because this np_any, what it checks is that it checks if the current pixel has any value similar to this pixel. So for example, if the current pixel has a value of 100 here, but it has 255 for green, then this will evaluate to true, this expression. So it's less restrictive. Let's check the output. Now it's much better, and I would say, unless you are an image processing critic, you wouldn't notice that this giraffe doesn't belong to this group of zebras and this other fellow giraffe. So it's quite a good blend, but you can do better by experimenting with these values. Now, the next problem was that this image is bigger, but this one here is just a portion of the background image. We can fix that by using cv2.resize, and we resize the background image to the width and height values of the foreground image. In other words, the background image will have the same size as the foreground image. So let's place that into a variable. Resized background is equal to that, and then here we want to play with the resized background image. So the current pixel of the foreground, if it's green, it is replaced with the current pixel of the background image. Run that and check the output. And now I think we get what we wanted. So the giraffe was there, the safari was there, and this is the output. And this is our script. Thanks a lot for following this video, and let's move forward with more videos. See you.